Hey friends, welcome to today's workshop, Type-Safe GraphQL Apps with TypeScript. My name is Powell, and I'm a Principal Cloud Advocate here at Microsoft. I've been doing web development for about 15 years or so. A lot of it has been server-centered web development with things like classic ASP, kind of showing how old I am there, through .NET and Node as ways of building applications. And then front end, I've used a lot of different JavaScript libraries in the way that we can tackle building front-end applications. I've also done applications across the spectrum of the way that we can access data from our backend systems, from custom-built API stacks for websites through REST, OData, and more recently, GraphQL. So today we're going to focus on the GraphQL side of that story and how we can do data access. If you want to get in contact with me after the workshop or ask me any questions or anything like that, feel free to reach out with the contact details that you'll find up on the slide at the moment. But for this workshop, well, it's going to be a hands-on workshop. You can follow along as I go through it over the next period of time while we run through the exercises, or you can cover it off in your own spare time if you prefer to do it that way. So let's just talk a bit about what you're going to need to get set up on your machine so that you can contribute to and play through with the exercises. First off, you're going to need to have access to the code. You'll find that on my GitHub. I've created a short link there for you at aka.ms/GraphQL-workshop/code, or follow the QR code. I've got QR codes around all the links that I've got in the slide deck so that make it easier for you to access. But this has got all of the code for each of the individual exercises that we've got throughout the workshop. So you can start at any of the ones that you want to start with, or you can start from the exercise 0, where we're going to start with when we get into the code in just a moment. For the workshop, I've set it up to be used with VS Code's remote containers or dev containers development experience. This creates a Dockerized environment in which all the dependencies and extensions and everything you're going to need are going to be pre-installed for your machine, so you don't have to go out and make sure you've got the right version of Node, the right third-party tooling, and all that kind of stuff set up for you. The dev container will take care of that for you. You can learn more about dev containers at aka.ms/GraphQL-workshop/dev containers. And that'll prompt you when you open up in VS Code, and we'll see that again when we get into the exercises shortly. If you don't want to use dev containers, or you're not using VS Code, or you don't have access to Docker on your machine, you can still follow on the workshop. It is designed to be used without dev containers if that's your preference. But for that, you're going to need to make sure you set up some of the prerequisites as well. You'll need to use Node version 14. That's a dependency that we've got within inside of this workshop for how you'll be able to work with the code base and how you're going to be able to run the different servers that we will be standing up. You obviously need some form of a text editor, whatever flavor that might be, works best for you. And you're going to need the Azure Function core tools. I'm going to be using Azure Functions as the way of hosting these GraphQL servers that we'll build throughout the exercises. You could deploy this to Azure at the end if you want. It'll be all set up and ready to go. But for local development, we'll use the Azure Functions core tools, which again, you can find out more about following the short link there I've got on the screen, aka.ms/GraphQL-workshop/func. And that will just allow us to do local development without having to have any kind of cloud connections. So what's this workshop all about? And what are the things that we're going to try and cover off in here? And what's the problem ultimately that we're trying to solve? Well, we want to work out how we can use GraphQL to build applications. It's a very popular way of building web applications these days, and it solves a number of different problems that we have with other ways we could do APIs. And the thing about GraphQL is that it's a type-based data access model. We define a schema, we define types within inside of that schema, and then we have those as the way that we can communicate between our client and our server. But then when we're building a TypeScript application, well, we have a type system that we're building with TypeScript. And this is a disconnected type system that we've got between our GraphQL types and our application types. So we want to work out a way that we can bring those together, because by having two independent type systems, well, we've got places where we might have mismatches. We might add a field to our data access model or our data access design that we've got in GraphQL schemas, but we don't represent those properly within inside of our TypeScript schemas. So how do we make sure that that all works together nicely? Let's have a look at just an example in code. On the left here, I've got my TypeScript. On the left is the GraphQL schema that I've defined. And it's got some enums, it's got some types, and they kind of look JavaScript-esque, but they're not really JavaScript at the same time. There's some similarities, but they're obviously clearly different. But then on the right-hand side, we're using our GraphQL resolvers. So these are the things that are handling the requests that have come in from our client at a server level, and they need to work with those same types. How do we make sure that when we've got a field called ID or question or correct answer on a question type, well, that's the same casing that we've got, it's the same spellings that we've got when we're working with that inside of our TypeScript application. Well, we're going to be working out how we can generate those TypeScript types, or how we're going to work with those TypeScript types from our GraphQL schema. And there's two ways we can go about doing this. The first is a schema first approach. This is where we take the types that we've got within inside of our GraphQL schema, and then we're going to turn those into TypeScript definitions, because they kind of look like JavaScript types. And like I said, there are some different differences there, but they're kind of the same. We should be able to extrapolate enough information from them to be useful. That this will help us have a clean separation between our application schema and the application itself. So that's one of the advantages of a schema first approach to data design. For this, you can use a tool such as GraphQL Code Generator, which will then take the GraphQL schema that we've defined and then generate TypeScript definitions from that. You can also generate definitions for a bunch of other programming languages, but they're not relevant for us at the moment. We're really only focusing on TypeScript. The other approach is doing a code first definition of our data structures. So this is where we take our TypeScript objects and the types that we're creating inside of TypeScripts and annotate them in a way that we're able to extract the type definition to make our GraphQL schema. So instead of having a separate schema file, we have a very clear relationship between the types within inside of our application and the GraphQL types that we're going to be running from our schema. If you want to go down a code first approach to doing GraphQL schemas and GraphQL applications, then I recommend you check out typegraphql.com. For the workshop that we're going to be doing today, we're going to go with schema first because that's my preference and that's the way that I wanted to show you how we can combine these two separate type models together into a single application. But that's enough slides for now. It's time to jump over and actually get into our workshop and start building out our exercises. I'll see you in just a moment. Here we are over in my GitHub repo for the workshop that we're going to be doing today. And I just want to give a quick run through of what's in the repo so you know where we're at, what we're doing, and how you can find the different things. As I mentioned on the slides before, you can get access to this repo. It's on my public GitHub at github.com/aaronpowell/GraphQL TypeScript workshop, or on the short link, aka.ms/GraphQL-workshop/code. And you can close this repository down, fork it, do whatever you want, and you're all ready to get going. And we'll see that by just jumping over to VS Code. Here we are in VS Code. I've got the repo down and I've opened up the first step of our repo. So there's two top level folders that are important: completed and steps. Completed is the fully completed application that we're going to build over the course of the workshop. So if you want to go through and get some spoilers of what it's going to look like and how it all comes together, you can just jump through to that one, start it up, and you're good to go. But if you want to go through each of the exercises and build it out, well, then I recommend that you jump through to the steps folder, and there's 8 steps that are in there, numbered 1 through 8, and you can work through them through the individual modules in that regards. So here we are in step 1. We'll get started in actually building in step 1 in a moment, but let's just look at what's in this particular folder so we know what things are there. At the very top, we've got a dev containers folder. So this is if you want to use the dev containers or the VS Code remote extension to run it inside of a Dockerized environment. That's just got the information on how to bootstrap and get everything up and running. It will install the appropriate extensions that you'll need in here, such as the GraphQL support for VS Code, some linters and prettiers and stuff like that. So you get good code formatting and all those sorts of good things just to make sure that you've got a good, consistent editor experience. The next most important folder is the API folder. This is where our GraphQL application is going to live, and it's what we're going to be building in the steps as we go through. And then we have our sources folder. This is where the front-end application, so the front-end application is a React application, but the stuff we're going to be building it's not specific to React. You could use it if you're using Angular or Vue or Svelte or any other JavaScript framework. You could just use the appropriate GraphQL bindings for that framework. But we're going to be doing React, but we're not really going to go into the React components until kind of the very end of the workshop when we have completed building our GraphQL server and we're looking at how we can use that from a client side. So that's a lap around our repository. Join me back here in a moment where we're actually going to start off with our first exercise and building our application. So it's time to get started building our GraphQL server. We're going to be using the Apollo implementation of the GraphQL server. And as I mentioned before, I'm going to be running this in Azure Functions as part of the workshop. But the patterns that I'm going to go through here are applicable for any bindings that you've got for Apollo server, whether you're running it as just the Apollo server core, just like its own self-hosted web server, using something like Express or any other ones that are out there. It's the similar sort of things that you can do here. You just have to change the npm package that you're going to be using. And probably just some nuanced bindings of exactly how you start up the server. But let's get going. I've got the README here open on screen. Every single step of the way we'll have a README that talks through what we're doing in this particular section of the workshop so that you can follow along as well, and you can copy the code snippets and the commands that we're going to be executing and things like that. But the first thing that we've got to do is we need to open up the VS Code terminal, and I'm going to come through and go to the API folder, and then we're going to install our Azure Functions bindings for Apollo. We're also going to install the GraphQL npm package. So let's kick those off. They'll take a moment or so to install. Ta-da, really fast. I'm obviously having a good internet day today. So that actually installed a whole lot quicker than I was expecting. But here we go. Now we need to create an actual Azure function that we can use to run this GraphQL server in. So I'm going to do that by using the Azure Functions command line tool. So that's the func command. You can either use npx because it is a local dependency of the API folder, or if you're working inside of the dev container, func is actually installed globally, so you can use that one instead. But I just have it installed as a local dependency for those people that are not using the dev containers. We're going to use the HTTP trigger template, and we're going to name it GraphQL. Okay, that's created. We also have another Azure function that's already been created for us, which is getMessage. That's just there as part of the template we started with. But let's go ahead and delete that one because we're not going to need it going forward anyway. Okay, so let's have a poke around. If this is the first time you've used Azure Functions, let me just introduce you to a bit of what we've got in here, and I'll close the terminal so we've got a bit more space. Azure Functions it's an event triggered platform, so we can have events that come through from a variety of different models. They could be triggers coming from like queues, they could be timer triggers, so essentially cron jobs, they could be from service bus, a whole bunch of different things that are available, including a HTTP trigger. So first up here, we've got in this function.json file a declaration that's stating we have an input binding, so the thing that's going to be coming into the function, and this is a particular trigger type of HTTP trigger. So this is when a HTTP request is made to this Azure function, it will perform something. It's going to have a context member called req, which is how we can access the HTTP request as it's come in. And it's going to support the methods get and post, which are also useful ones when we're working with GraphQL servers. We want to predominantly go through post, but we can do get operations using the get HTTP verb as well. We then have an output binding. It's the second binding that we've got inside of this declaration file here. This is also of type HTTP. So this is just meaning that we can send a HTTP response back, indicated as an output by out. And by default, the template will create it so that it's going to expect you to create a member on the Azure Functions context called res, which is where the response is going to be put in. Now, for Apollo, we're actually not going to use a named variable like this. We're going to use a variable, we're going to use dollars return. This basically tells Azure Functions that whatever the function that's like the JavaScript function that's been executed, its return value is what you'll send back over the HTTP response. Now, this is just the way that Apollo wants it to work, because it doesn't know that you've named the variable like the context output binding as res or response or thing for client. It doesn't have that understanding of the way that you configure this functions.json file. So it just expects that you want to return from that function itself. The other thing here we've got is the index.js. Not JS, index.ts. This is a TypeScript file, not a JavaScript file, which has just got the boilerplate code that has been scaffolded up. I'm going to delete that because we don't need it. Instead, we're going to import from from Azure Functions, not Core Tools, from Apollo Azure Functions, and we're going to import two things from here. We're going to import Apollo Server, and we're going to import GQL. So Apollo Server is the thing that we're going to be starting our GraphQL server in, and GQL is a way for us to define our GraphQL schema. So let's set that up, and we're going to create some type const type defs. So these are going to be our type definitions that we've got for our GraphQL schema. So we'll do GQL, and we'll do our backticks. And let's put in here, I'll do type query, and then we'll open our squiggly brackets. So this is defining a type for our GraphQL schema. It's going to be named query, and then it's going to have a member called hello, and this will be of type. We'll do string. Should we make it a not nullable string? Let me just check my notes. We'll leave it as a nullable string because that's what I had in my notes, and if you're going to copy along from them, it's probably best that I make sure this is the same as much as I can. Next, we need to tell the GraphQL server, once it receives a request for of type query for a member called string, well, like, how's it going to process that? What does it need to do? So this is what a resolver is for. So we're going to create some resolvers, and then this one will have a member called query, which matches our schema's type definition. And then on this query, we're going to have a hello, which is going to be a function, a JavaScript function, which will then return hello workshop folks from GraphQL. Cool. So what the GraphQL server will do is we'll take the type definitions we've created, combine them with our resolvers to get that value to be able to send back to the client. So now we need to make our server. So let's create our server. Const server equals new Apollo server, and we'll pass in our type defs and our resolvers. And then lastly, we're going to export default the server.create handler. So server.create handler is going to tell Apollo that it needs to create an Azure Functions handler, so a thing that's going to be able to respond to the Azure Functions when a request comes in via HTTP. Then we're exporting this out of this module so that when the Azure Functions starts up, it knows how to, it knows that this is a function to execute and what it's got to do. So that's all done. Like, this is our first start of our basic GraphQL server. Let's pop open the terminal, and we're going to run npm start, which will run TypeScript, compile the TypeScript to plain old JavaScript, and then it's also going to start the Azure Functions local tools so that we have that server up and running. There we go. It's up and running. We can click this link here, and it should pop into my browser somewhere, or it should have. Where do we go? There we go. Excellent. And here we go. Here is our GraphQL server up and running. It's just an endpoint that we could hit with something like curl if we wanted to from the command line, or we could use a GraphQL IDE such as the Apollo Studio, which is what it's prompting us to do here. So let's go through to that. Now, the one thing if you are using Apollo Studio is you got to make sure that you enable cores on the GraphQL server that you're running. I've already got that set up in the template with Azure Functions. We just need to tell it to run with cores enabled. Otherwise, it's not able to query across this because it's all running with inside of our browser context. But it's built up whoops. Let's not expand all my windows like that. We've got our query operation that we've got here. We can have a look at our schema. So we have our root. It has a type query, which has a field hello, which has no description. We haven't put anything on there, but that's our basic query. Let's delete some stuff out of there in the variables that we will be using later on. But we have our, this is our query operation. We're just calling it's called example query. So we name it in the response. We're requesting the hello field. If we execute that, we get hello workshop from from GraphQL. So that's what we did. That's what we expected. All done and dusted. And we have created our first bit of a GraphQL server. I'll be back in just a moment and we'll continue on with step 2. Welcome back for step 2 of our GraphQL workshop. So we've got our basic server up and running. where we can hit that. We can start up, we can hit in an IDE or from curl or something like that, so that we can perform our GraphQL queries. But this is, well, it's still all embedded inside of this one file. So now we're going to look at how can we extract this out to a separate file. So what I talked about in the slide deck right at the start is that we're going to be going down the path of doing a schema first GraphQL definition, and then we're going to be extracting types from that schema. But we need to have that schema available somewhere for us to be able to extract that. So let's start by moving what we've got here as our GraphQL server out into a separate schema. I'm going to do that by creating a new file, and we're going to call that schema.graphql. And we'll just put that alongside our index.js file. Oh, sorry, index.ts file. And then I'm going to grab the type definitions from here, put it in, and that's the first step of starting to extract it. But now it's in a separate file. We need some way that we can actually turn it into the type defs that are actually used in here. And to do that, I'm going to bring in a couple of new NPM packages. We're going to be importing, well, let's make sure I'm in the right location. There we go. We're going to be in the API folder, so we install these packages to the correct npm package.json file. So let me kick off the install, and I'll talk about what we're installing while that's happening. We're installing 3 new packages. We're installing, they're all from GraphQL Tools, which is an open source project that has a bunch of different things to help making GraphQL projects easier. We're installing the GraphQL load. So this is loading a schema like definition into something that can be consumed by a GraphQL server. We're using the file loader, so we're able to load from files on disk. They've got a bunch of different loaders, so you could do like a remote schema loader. So if you were creating a GraphQL server that was wrapping around a bunch of other GraphQL endpoints, you could use that. And then we've got tools that will convert this like string representation of a schema into a GraphQL schema that can be consumed by Apollo. So they're installed. Let's go ahead and start importing some of these things. So I'm going to delete this chunk of code from here, because that's not how we get our type definitions anymore. And we're also not going to use the GQL import from the Apollo server Azure functions. Instead, we're going to create our new schema. We'll do const schema. And for this, we are going to use load schema sync. The reason I'm using load schema sync in this case is because that we need to be able to load this before we try and create the Azure function. But if you're running in an environment where you could do asynchronous operations and then before your server starts up, then you might want to use the load schema synchronously, which returns promises and stuff like that. So that's, but that's just a nuance of this particular hosting model. I'm going to import join from the path node module. So we're going to go join so that we can create this path to the folder from path. And then we'll do join. And we are going to be joining from dir name, and then we're going to, so this is from where the compiled JavaScript file will reside, which is actually going to be in a different location to where the file currently is, because I haven't modified my tsconfig. It's going to be putting it into a dist folder. So we'll need to do some directory walking. So we're going to need to go up a couple of levels. And then we will go into GraphQL, and then we'll go, what do they call it? Schema.graphql. There we go. Okay, so we're going to load that schema, and then we're going to use a loaders, and we will use the, so we have to provide an array for loaders, and we'll use a new GraphQL file loader. There we go. Pass that in. Excellent. So there we go. We have our schema. Now for Apollo, previously we were passing in these type definitions, but instead of doing that, we're going to be just passing in the, we're going to actually resolve the schema and resolvers and kind of merge them together into a single object. So let's delete this for the moment. Let's pop in a new line, and we are going to have a schema instead. So this fully combined schema, rather than getting Apollo to do that, we'll use the add resolvers to schema method, which comes from one of our GraphQL tools packages we've just installed. And then now we're going to pass it in the, whoops. IntelliSense is getting in my way. We're going to pass in the schema and the resolvers. Okay, there we go. So we've imported load schema sync from GraphQL tools/load. We've imported the add resolvers to schema from the GraphQL tools schema, which will take the resolvers and our imported type definitions and merge them into one. We're using the GraphQL file loader from GraphQL tools GraphQL file loader to stand that up. And then finally, we're doing path. We're grabbing join from path. And just to show that this is all still working, let's do npm start, kick off our server. And the message here is hello from our GraphQL backend. That should be, let me just check, did that get up and running? It is up and running. Let's execute the query, and there we go. Hello from our GraphQL backend. So that's worked, it's done. Our server is up and running. All we've done is we've moved the schema off to a separate file instead of having it embedded inside of our TypeScript definitions. TypeScript file. And this just means that as we get a bigger and bigger schema, well, it's probably preferable that we have it not just like loosely embedded within inside of our code file. Now let's start building a schema for the actual application that we're going to be building. Because so far we've just got a bunch of prototyping code essentially in there. The application we're going to be building is a basic trivia game. So we're going to be able to, we're going to need to be able to do things like ask questions. We're going to have players. We're going to have game representations, and we're going to have player answers and stuff like that. So let's start with our grab our schema here, and we're going to delete off what we've got there. I'm just going to copy stuff in from my notes, so you don't watch me typing continuously because, well, that's the sort of stuff you'd be normally fast forwarding. First thing we're going to do is define a question. This question is going to have an ID, which is using the GraphQL scalar type of ID, and it's not nullable. We have a question, so the thing you're going to display to the user to ask them something, and that's a string. We're going to have a correct answer, which is also a string, and these exclamation points or bangs are used to indicate that this is a not null value. And then finally, we're going to have an array of answers. So that will include the correct answer. So it'll be all the answers that could be given to a question. And that will be an array of non-null strings. And also we will not have nulls available for answers. So you can't have just you can't get null back if you request an answer, the array of answers. Now we need to define a game. For this one, we're going to, again, I'm just going to copy it in from my notes. So the game is going to have some game state represented, which we're going to need to create an enum in just a moment for. We're going to have players, so we're going to need a player type, and we're going to have questions. So this is referring to that type that we just created, that question type up there. It is then, so those won't be null, and they're inside of an array, and that array will have 0 or more objects. So you'll always get at least an empty array back for that. So let's define an enum for our game state. There's going to be 3 states the game could be in: waiting for players, started, and completed. So just representing that as an enum value. And again, from a TypeScript standpoint, we're familiar with enums and classes and things like that. So this is starting to look and feel a bit like a TypeScript types setup. Obviously syntactically a little bit different, and the subtypes like ID are a little bit different, but we can see where this relationship would be between our schema and ultimately what we're doing. The last type we need to define is our player. Here's our player. They're going to have a name. We're going to be able to get from a player a specific game that they're in, and we're also going to be able to get all the games that player is in. So this one here on line 24, this is a member of a GraphQL type that requires an argument to be passed to it that is then used to give us back a value. So they will be able. So we'll be able to say, I want a game. Here's the game ID I want, and then that will give us back a game for that particular player. Or we can get back, I said, all the games that player has played in. And then the last thing that I'm going to add to our schema is just a way to represent the answers that a player has given to the game, and we've got to call that player result. So when they submit, we're going to have the name of the player that this result is associated with, the question, the submitted answer, the correct answers, and whether or not this is a correct answer that they've submitted. So this is maybe more of a type that is encompassing a bunch of stuff that's internal inside of our data sets. We might not actually store player result in this shape down in our application, but this is a way that we're representing it as a response from our GraphQL schema. So we've got a bunch of types defined, but now we need to define in our schema how we want someone to query against those. Because right now, if we were to start this server up, we would have all these types, and I could go to, I could just get a player, or I could just get a game, or I could just get question, and it's very loose in the way that our schema is defined and the way that someone can consume data out of it. What we probably want to do is give some indications, some starting points for people to be able to query from, and then get subsets of data, because then we can build our backend to optimize for the way those queries are happening. So let's go ahead and define a bunch of queries. So here we go. We're going to have 3 queries that a user can, or a client can make against our GraphQL server. The first is that we're going to be able to query for a game by its ID, and that will return us a nullable game. So if you give us an ID that doesn't exist for a game, then you're going to get a null value back. If you provide one for the game, then you're going to get the game itself back. You're going to be able to get back all the games. This is maybe like an admin function that down the track you would have some way to indicate that you could only get this if you were of an admin user or something like that. And then we're going to be able to get back a player results. So for a game and for a particular player, what were the results that they gave? So what were all the answers they had for those questions? Again, maybe like in a more ruggedized production application, you might have some way that you could say that you can only do this if you are that particular player, and have some way to map all that together. We won't be going to in that level of detail within inside of this workshop though. Lastly, we need to define that this is not just a series of loose types, but a schema that you can query on in GraphQL, and that's what we use the schema keyword for here. So the schema is going to have a query available on it, and that's going to be using the query type, which is this one here on line 37. Now, if we do npm start, if I can type correctly, there we go. Let's just load this back up into the Apollo Studio and have a look at what that looks like now. There we go. Give it a moment. Our GraphQL server is up and running. Oop. Looks like I also forgot that I was jumping the gun here. Let me expand out this error. Just collapse off to the side. What that is? Where? Go away, little thing on the side. There we go. That's what I wanted. Okay, so let's just have a look at what this error is saying. So what it's tried to do is it's tried to load the resolver hello against the schema that we've provided it. But, well, hello doesn't exist in our schema. So we've said, like, here's something that you can resolve for, but the schema has no way of allowing you to resolve for that. You don't have to implement a resolver for everything within inside of your schema, but every resolver has to map through to something in your schema. That's an enforcement that GraphQL tools will do when you're trying to generate a schema object for your type definitions. So let's just come back to index.ts, and we'll just empty out our resolvers, and we'll hit npm start again. Now we should have our server up and running. It still won't do anything because we haven't told it what to do when you're looking for these different things. But at least we can see that schema now inside of here. So let's come back to our root. Okay, so let's just reload that. Make sure that we don't have a cached version or anything like this. I just realized I should zoom in just a touch more. Okay, there we go. Now we can see from our root, we have a single type that you can explore through, which is query. We don't like player and game and stuff like that aren't available as just explorable types. But if we go into here, we'll see that we have game, games, and player result. So we could get back a game and then get back like a specific game. And then that we can see that it requires an argument called ID. Here are the fields that we could get back. We could get back like an array of players or an array of questions. And then from that, we can get back the fields that are available within inside of the question, so on and so forth. You can see it's pre-populated an example query here using games. And it said for games, we're going to get back the ID, but we could say get back the ID and we could get back questions, which from that we would say we want the question and then and then we want maybe the answers. Yeah. So like that might be a query that a client would want to perform to get back all the questions and the answers that they have for a particular game. Now, if we were to run this, it's not going to work because, well, we haven't implemented any of those resolvers. But that's all for this particular step. This was more about how can we start extracting things out and seeing where we can start restructuring our existing code base so that we can continue on in building out our application. Join me back here shortly for step 3, and we'll start building out some of the resolvers to handle what we can do with our new, more expanded GraphQL schema. For the third exercise in our workshop, we're going to start building out a way to interact with data inside of our GraphQL application. There's 2 ways that we could do this depending on what you want to choose with inside of the workshop. I'm going to go with the simplest way, which is an in-memory data store. Obviously, the downside of that is that every time we restart our server, we're going to lose all of our data and we'll have to start again. But it's just kind of the simplest one for us to go through from a workshop exercise. If you want to do a persistent store, I also have inside of the Git repo instructions on using Cosmos DB as a backend data store for our GraphQL server. So then you get that level of persistence. But obviously, you will need to make sure you have a Cosmos DB instance that you can read and write to. So yeah, that's why I just said from a example standpoint and from a quick setup from this workshop, we'll predominantly go with the in-memory one. But you'll see the Cosmos one appear every now and then as we go through the rest of the exercises. With Apollo, we actually have a data sources concept that's built into it. It's another thing that we can add to our server. If I go here, we'll see that data sources is another property we can add to our server config. But before we can do that, we're probably going to need to, well, go ahead and start building them. So for that, I'm going to use some TypeScript interfaces to represent what our data sources are going to look like. And then we're going to create some data models that will represent the way that we're storing that data in there. So let's start by we'll create a new folder. We'll call it data inside of our GraphQL project. And then I'm going to create a new file and we'll call that types. And inside of here, I'm going to create, we're going to export an interface base, and we'll start with the question data source. Because questions is probably the first thing that we're going to want to be exposing from here. Is that like a way that we get questions? Because if we can't get questions, it's going to be really difficult to make our game. We're also going to need to create, well, actually, before we go ahead and create some data models, what are we going to use to make some questions? I've gone ahead and actually provided a bunch of questions inside of the Git repo. That's what's inside of this trivia.json file that's now popped in. These questions I've exported them from the Open Trivia database, opentriviadb.com. It just kind of saves me coming up with my own questions. And if we have a look at the data structure of this particular question, and then let's bring up our GraphQL schema across to the side. We'll just move that across to the right. Where did my file go? There it is. We'll see that they look close. They look close in structure. So we've got like an ID, which is there. We've got, well, category and type difficulty. Like we're not obviously using those. We've got a model type. So this model type is really just there for Cosmos DB so that we can detect the different data structures that we're storing with inside of the database. We've got question, which maps through to question. We've got correct answer, which, well, I mean, maps through to correct answer, but you'll see that we're starting to see like some differences in casing or stuff like that. And we don't have we don't have a correct, we don't have answers as a field inside of our data structure. We just have incorrect answers. So we would assume that's kind of an aggregate of correct answer and incorrect answers together. Like that's how we would get back our response. So this is where you don't want to expose your underlying data structure from your database directly through your GraphQL schema. So we need to do like that kind of translation, and this is kind of where we start building out our type differences, because we're going to model these we're going to model these types inside of our data source that map what our data source has. So let's create, we're going to start with an enum just for that model type. So we'll create an export enum model type. And then this is going to have a question, which will be, we'll just use like string enums question, because that's what we've got in our data set. User, which will be user. And so these are the different top level types. Game, which is going to be game. And lastly, we'll have user answer. Cool. Okay, so there is our enum created, and we'll create like a model base type, and that will just have an ID, which is a string, and we'll have a model type, which is that model type. So now we'll create our question, and so let me just copy this in. That's enough of watching me fumble around typing. There we go. You could use interfaces, you could use types, or you can model these whatever is the preferred type structuring that you want to go with. But I'm just using types, using the type keyword here. But yeah, feel free to use interfaces if that's more preference for you. Entirely up to you. But yeah, you'll see here that we're modeling this as we had with inside of our data set. Now we need to go ahead and create some members on our question data source. That is what we're going to be exporting. So we're just going to add two members to this. Get question, which will take an ID for that particular question and return a promise containing the question model. Otherwise, we will get all the questions, and that will return an array of question models. Cool. That sounds pretty good. And now let's go ahead and create our in-memory implementation of that question data source. So let's go in, whoops, delete that. And we'll go new file in memory / question data source.ts. There we go. If you put a slash in a file name when you're creating it in VS Code, it will automatically create that folder hierarchy for you. It's a good tip that it took me a long time to realize that was a thing. Okay, so let's scaffold out this. So we're going to have our question data source. It's going to implement the I question data source, and we're then going to need to, well, at least implement the basics of that interface. Done. But, well, as I said, Apollo has support for doing our data source. It has this as a model. And what it does by using that pattern that's got in there is it supports things like caching and some optimizations that you can require when you're building out a data-centered solution. You probably want to have some level of caching and things like that. So to do it, we're going to import a new package into our API project, which is the Apollo Data Sources npm package. This just gives us the base type that we're going to inherit from when we're building our data sources. So let's make this class we've got here. It's going to extend data sources, which we'll import from Apollo Data Sources. We're going to have our questions, etc. And I'm just going to copy and paste this in from my notes. Okay, that's right. I've written a little array randomizer function that because, well, we don't want the same 10 questions every single time. So I'll just have an array randomizer, and we'll create a dreaded like utils file somewhere. So let's just get my import statement ready. We will create that file. Didn't add that .ts extension because it didn't know to. And I will have to go to my notes and grab that array randomizer function, because it's one of those things like I've written it plenty of times, but do I ever remember what how to write an array randomizer? No. I just easily copy and paste it from elsewhere. It's easier to do that. And you just have like in the snippets that you're always going back and forth to in your own application. But there we go. Okay, so the way this is working is it's going to import that JSON file from disk. So just that trivia template file that we had there, and then load that into a private array of question models. And then if you get a particular question, whether they're just doing promise.resolve and then finding that question by its ID, otherwise, randomize them, take the top 10 off that randomized array, and then return those out as questions. Okay, so now we need to, let's start wiring this into Apollo, because at the moment the data source is sitting externally of that. So I'm going to go back to the data folder, and we'll create an index.ts file where we'll export a couple of things, which another thing I'm going to need to create is an Apollo context. Let's just create that file. So before we go ahead and create that, let me just kind of explain what the point of the Apollo context is going to be. A context in Apollo is used to indicate what things are available, like from kind of like a pseudo dependency injection standpoint. But we also need to strongly type our data sets, data sources inside of here, so that they're aware of, they can be aware of Apollo context if you want. So I'm just going to create an interface that will, or a type that will represent that, that will then strongly type that throughout the rest of our application. We're also going to use it a bit later on as we build out more and more of our complex type system within inside of our application. But I'm going to need it earlier than I kind of initially wanted, so we'll have to put that here. Grab this Apollo context. And we're going to have three different data sources inside of here. A game data source, question data source, and user data source. We haven't created the user and question ones yet. We'll come back to those. Then we'll get rid of that .ts extension. There we go. And then we need to just strongly type this thing here. This strongly typing stuff that changed in Apollo 3, which came out about 2 weeks ago. It used to be a lot more liberal in the way that its type system worked, but yeah, I've had to update this workshop to support that with Apollo version 3. So let's import the in-memory data sources here, and then we'll call this data sources is going to be the in-memory data sources. Excellent. All right, so let's go ahead and create the rest of our data sources that we've got that we're going to need with inside of our application. So what do we say we're going to need? We're going to need an iGame data source. So we'll export an visual interface, export interface iGame data source. Come back to the implementation of that shortly, and then we'll have a user data source, and we'll export that too. Export interface. There we go. Okay, so what sort of things we're likely going to be needing to do from that? Or actually, no. Probably want to have our other data models in here, because we're going to need them while we build up the rest of it. So we'll have a user model, which is going to be have the name. There are provisions for this to support like identity provider logins, but we're just going to make it simple. It's just going to prompt you for a name. There is the building blocks if you wanted to have a more robust like identity solution, and like the concept of users having different roles that they're associated with. So you could have that admin role that can get back all of the games or get back across user boundaries and things like that. Our user answer model, and then finally our game model, which has our state as the 3 different states, players, questions, and answers, and then using these associated types within inside of TypeScript. We're going to now need to create a couple of additional implementations. So I'm just going to grab those from where I have created them earlier. Okay. In the effort of saving people watching me type, we'll create a game data source.ts. Okay, so in this one, we're importing the types in the data source as per previously. Where this is going to receive an array of games. This is just so that we have them as a shared model setup that means that as Azure Functions spins up and spins down, it might trash the data set. This just allows a little bit more persistence for in-memory. We're going to get back our user games. So here are all the games for a particular user. So we can get back that as a array of promise array. So we're going to filter through that. Update game, get the games, get back a single game by its ID. We're also going to have a mutation function, which I haven't got around to. We haven't got around to doing mutations yet. So that's just kind of a placeholder for when we're going to need it later on. Let's add to our interface up here the methods that we're going to need: get game, get games, etc., etc. Similarly for the user data source, we'll add from my pre-existing notes. So we're going to be able to get back a user by its ID, and we're also going to be able to create a user. And then the last thing we got to do is create our implementation of the user data source, which will be new file, user data source.ts. There we go. We'll then have all of these added here. That will be user. So this is going to be a user. Yep. New in-memory user data source. We'll have to do that import properly, and then game. Let me check. We call it game, or we call it games. The joys of live coding. Well, this isn't technically live coding, is it? I mean, I am going to be doing this, well, and this isn't really live. It's kind of live. Anyway, now I'm just talking to myself on, on recording. It's kind of stuff that maybe I should delete in editing, but I probably won't. Got to make it seem like, and then we want to go home. You gotta make it seem a bit like realistic that I am going insane and talking to myself. And in a real workshop, I'd still be talking to the people as well. Anyway, there we go. Okay. Oops. Save. Okay, so now we have implemented our 3 data sources: game, question, and user. We've imported them. We've imported the appropriate models. We've created up our in-memory data sources. It's user, question, and game. Those are the ones that we're going to need. We're passing those in as the user and game models. We're just having those just kind of cached outside of the data sources because it will actually create this. It will execute this function every time the request starts up. So we kind of it basically provisions the data sources each time, and we don't want them to trash the games like every single request. So better that we do it that way. All right, so that's our data sources all set up and ready to go. I need to. Oh, I haven't. We need a way to generate IDs for users and stuff when they join. And again, this is another little code snippet that I've got inside of my utils file that we can copy and paste in. So the ID generator is just going to it's just got letters of the alphabet and then randomly select 4 of that. That's how we're going to create IDs. It's not. We could use UUIDs if we wanted, but random 4-character codes are just as easy. And it saves me importing another NPM package. But there we go. Our data sources are ready. Apollo is aware of them. Oops, where is our index file? So Apollo is aware of them. They're imported here. So when a request comes in, a resolver would have access to those data sources, but we haven't built any resolvers yet. They're extracted out to this separate file here, but we haven't actually implemented them. So, well, I guess we better do that. So come back in just a few minutes. Give everyone a break. Although I suppose for a break, you could just really pause the video. But, well, yeah, have a break and we'll start implementing our resolvers to use these new data sources that we've created. See you shortly. It's time for us to start building our resolvers. We've got our data sets ready, so we can query our data sources, we can get back data, we could theoretically create data, but we haven't actually implemented that yet. The first thing we want to do is, well, we want to be able to get some data back because we can't start a game until we actually be able to start querying for it in any way, shape or form. Now, when we built our schema back in step 2, we created a type on it called query, and that had the 3 entry points that we have for interacting with our data sources. We have getting back a game by ID, getting back all the games in our system, and getting back player results. Let's leave player results aside for the moment and focus on getting back a game or games by from our system. Now, for that, we're going to need to implement a resolver because, well, the way Apollo works is that it will just, if you don't define a resolver, it'll put a default resolver there. So it will attempt to just return the most basic version of whatever that object type is. Well, we've written a bunch of custom types, so it doesn't know how to resolve those. So we're going to come into our query in our resolver. So this is in a file called resolvers.ts in our GraphQL project. And this is where we start defining out these methods. So let's start off with games. So games is going to be a function and it's going to have to return something, but we don't have anything to return yet. So we're just going to throw a new error and we'll just say not implemented yet. Not implemented. Okay, so how do we work with those data sources we created? We created them in the previous step, but we want to make them available to us here. Well, a resolver function in GraphQL, or at least in Apollo's approach to GraphQL, receives a number of arguments passed in. The first argument we're going to ignore, which is a parent object inside of our GraphQL query hierarchy, because this is off the GraphQL schema root. There is no parent, so we can ignore that here. The next is any arguments that are provided to that operation is being performed. Games, as we'll see on line 37, doesn't have any arguments provided to it, so we'll just ignore that as well. And then we get our Apollo context. This is where we have our data sources available to us. And then that is going to have our game, our player, and our question, and all that kind of stuff available to us. Excellent. So now we can update this instead of throw not implemented. We can return data sources .game.get games. Oops. Oh, whoops, don't delete that. Okay, so let's do that. And then let's just pop our server and get that server up and running. And npm start. And let's just hit it. I mean, it's not going to do anything just yet because we don't have any games available. We haven't created any yet within inside of our application. But just out of like curiosity's sake, let's have a look at and make sure that it does return something that we're expecting. There we go. Let's reload our GraphQL server. Oh, it's happening. Need to grab some water. Okay, so we can use that example query that we had before, And this should return us, well, it returns nothing because, well, we don't actually have any games yet. But that has actually hit our server. We can prove that by, let's pop a breakpoint in here. Do I have my debugger running? I don't have my debugger running. So let's not pop a breakpoint here because it's not going to debug anyway. We'll leave the server running in the background because I've got the TypeScript watcher on. So as files change, it'll recompile them and restart our Graphql server. Next, let's get back an individual game. So again, we're just going to ignore because there's nothing above it. But this time, we do have an argument passed in. It's called ID. And then we're going to need to get back the data sources. And we'll return data sources game.get game. What did I call it? Get game. And then we're just going to pass in that ID. I think you can probably start seeing where some of the disadvantage of these disconnected type systems is happening. Like ID, well, it doesn't know how to do anything, and it is just it's an any type because it doesn't understand the type system that we had defined inside of our GraphQL schema. Like that should be a non-nullable ID, which is represented. It will be a string because that's the way that it's represented from a JavaScript standpoint. Similarly, our data sources, we know that's an Apollo context, which has data sources on it, which has game, which has get game as a function, but we've just lost any value that TypeScript could be bringing to us at this point in time. So this is where we're going to want to work out how do we improve that relationship between the schema types and our resolvers and the information that's available there. I'm going to go ahead and just copy in the implementation of our just going to pop in a big implementation here, which is the get player results. So this is now an async function because we're needing to get back a specific game by its ID. Actually, let me just reopen that. So it had two arguments, game ID and player ID. So we see game ID and player ID. Again, these are still any's because we don't have any type information at this point. Like we don't know that that's a game, but we know that this is returning a promise, so we can await on it. But you don't have to await with inside of a resolver. Apollo resolvers can either return an object or a promise that will return an object. So if you've got something that is going to return a promise, such as get game, you can just return that directly. You don't have to unpack don't have to await on it with inside of the resolver. Just we need this here so that we can then go through the game answers for the user for that player, and then build up this new object model. And we're still randomizing the answers set that gets sent down, so that even in the result, you don't get it looking too complex. Okay, so let's go back and just execute this with maybe a bit more of a complex query. So now we're getting back game, the state, player, ID, name, description, etc. Excellent. It works. It's not doing anything just yet because we haven't put anything in there. But I do actually have a sample game. So let me just pull this in. I'm just gonna copy this from my notes because this one you do not want me to want to watch me typing out because it is huge. And then we will just pop this into our games here. Model type. We need to import that. There we go. So there we go. Now we have a mock game in there. So if we hit run again, ta-da! Now we've got back our game. Here's its ID. It started. I'm the only player in the game. We have a whole bunch of questions that were asked, but we didn't actually look for any of their answers, but we can modify the way this query works. Let's get rid of those things that we don't want. We just want the question and the answers that are available. Oops, but now we've got an error. It doesn't know how to map that nullable field answers. Looks like we've got a mismatch with inside of our type system. And that's what we're going to start tackling in our next module. But that's all for module 4. join me for Module 5, where we're going to try and work out why I've ended up with an error here and how we can try and fix that. Well, that last segment didn't end so well. We had errors blowing up in our querying. We were lacking types information when we were starting to work with our resolvers. We didn't know what the ID type or the data sources, and we're starting to lose the value of what TypeScript can bring to our application. So now it's time to talk about how can we go from the types that we've got within inside of our GraphQL schema and bring them into our TypeScript application. We can start bridging the boundaries between those two locations. For this, again, I mentioned this in the slide deck when I first introduced the workshop. There are two approaches that we can do this. We can either do this in a code first or a schema first manner. We're going schema first in this implementation. So for that, I'm going to be using a tool called GraphQL Code Generator that's going to take our GraphQL schema and generate a bunch of TypeScript definitions for us. It can also be used to generate definitions for or type information for other languages, or if you're doing .NET, etc. But obviously TypeScript is what we're talking about today at TSConf, so it makes sense that we're generating TypeScript information. You can see from their website the kind of thing that it's going to go ahead and do. So we've got here on the very left-hand side, we've got a GraphQL schema that's been defined. It's got a custom scalar, which represents the date. So this is a custom primitive type that we've got. We've got our schema defined. We've got we've got a query. We've got some enums and interfaces and a bunch of different things that we could have with inside of a GraphQL schema that we have. And then we're running it through the TypeScript generator plugin that generates out this types.ts file here over on the very right-hand side. And if you've dug through the TypeScript type system, you're probably familiar with the kinds of things it's doing here. It's using maybe types, it's using exacts. We're exporting just type primitive types, so there's all the different scalars that are available. So there's ID, string, boolean, int, float. So these are the types that are available in GraphQL as the low level primitive. We've also got that date that was created custom with inside of our TypeScript schema. We have our query type. We have arguments that could be going into, say, like the user query that's appearing on line 9 of that schema, so on and so forth. So this looks really good. So we're getting a bunch of type information. That's going to be a great starting point. So let's go back into our Visual Studio Code. I'm going to pop the terminal and let's go ahead and start getting going with this. We're going to need to install a new node package, and it's called GraphQL CodeGen. Oh, it's at GraphQL CodeGen, being the scoping CLI. So we're going to install the command line tool for this. So it'll take a moment or so while that installs. And then this is going to give us a new command that we can run from our system that's going to then bootstrap up our schema, the type generating thingy. But we'll see that in just a moment. But we'll use the magic of editing to fast forward through the package install. There package is installed, and now we need to run the bootstrapper for GraphQL CodeGen. So npx, not nox. What is it? GraphQL CodeGen init. So this is going to ask us a few questions about what kind of project are we going to be building. Let's just move that off to the side so that we've got a bit more space that we can see. So we're going to be building a backend server. We could also generate like stuff for React or Angular, etc. We're not going to do that right now. We'll get to that later on when we actually start working with the React component of our application. Where do we want our schema, or like, where does our schema live? Are we working with a remote schema, or are we working with a local schema on disk? So this is going to be at /graph/schema.graphql. And we're going to be wanting to generate TypeScript definitions and TypeScript resolvers. So this is, so do we want to just generate like model types from our schema? So get our like a game, a player, a question, etc. Or do we also want to generate stuff that we can attach to our resolvers so that our resolvers can be strongly typed with information of the way those queries and things are defined with inside of the schema? So we want both of those. So we're going to select both of those. Well, they're selected by default. And let's just hit enter on that. And where are we going to output it to? So we'll output this to GraphQL/generated.ts. We'll generate an introspection file as well. So this is just information for other clients that might want to be connecting and consuming our GraphQL information. What do we name the config? We'll leave it config.codegen.yaml, which is just the default one. And then we'll create a gen script that's going to be added to our package.json. So we can do like npm run gen, and that will then generate our type definitions. Okay, so we need to do npm install first because it's added a bunch of new packages to support all of these all this generation that we're doing. And then we can do npm run gen, and we'll end up with that new generation file, the new generated file, sorry, with all of our TypeScript information. So we'll give that a moment to complete. There we go. And let's go npm run gen. And we'll see that, excellent, I got everything correct. And it has parsed our configuration. It's generated the outputs that we have requested. So let's just have a look at that now. If we come here, we'll see here is our generated. Now you probably want to add the generated and sorry, let me just close off the terminal so we've got space back. So this generated.ts, the GraphQL schema, and the GraphQL schema.json file, you probably want to add those to your git ignores, just because like these files churn quite a lot. Every time you run the generation, those files are going to be updated, and it could create a lot of noise in your git history. I tend to put them in exclude, and then just make sure that my build step runs generate before it runs the TSC, because otherwise we end up with TypeScript failures because it can't find these files. But yeah, so we can put those into our git ignore. Or I might already have them in the template, I forget. But yeah, let's have a look at kind of what we've got here. So we've got a bunch of types that it's defined up the top. That we have. We've got our scalars here. We have our game, which has, well, if we were to bring up, whoops, that's not where I wanted to be. Where's my move back screen? There we go. Sorry, new keyboard. I'm trying to remember where I've got my keys all mapped to. So if we go, what do we want? We wanted schema. Lost my train of thought there. And then we're going to pop that file over to the side. Okay, now we're back to where I wanted to be. So we'll add this kind of meta property of type name, so we can have a look at that in the response as well. We have our ID field, which is using the scalar type of ID, which again maps through to that there. We have state, which is nullable. That probably shouldn't actually be nullable. That should probably be a non-nullable field, but can't bother changing that at the moment. We have players, which is an array of player and array of questions. We have our game state, which is being converted into an enum and a string-based enum, because that's GraphQL will represent it as a string-based enum, so that's the way that it generates the TypeScript type for us as well. And then a whole bunch of other stuff that we've got. Excellent. That sounds pretty good. So the fact that we now have this enum for game state means that we can go ahead and probably update one part of our code that I wasn't super fancy on, but it was kind of the best that we had at that point in time. If we go to our types.ts and we come down to game state here, I have just that embedded as the magic strings, but now I can go game state and we can import that from generated. So I just automatically imported that. And now we're actually using the type information that we had inside of our model. But they're not 100% one-to-one mapping because we don't want to expose our underlying data structures all the way out through to our parent data structures. So we can't do like that direct one-to-one mapping. But, I call that generates in, I meant to type generated, but let me just rename that because that's probably why it's not getting picked up by git ignore generated. Delete generated. And then I'm just coming to the config YAML file, and then that should be generated. There we go. Okay. And we'll need to make sure that that's all updated. Excellent. Now, the other thing that we did was we generated the resolvers. So we can now strongly type our resolvers here. So we can go resolvers, and you'll see that that's going to import that from API generated. Ta-da! Done. And now, if we hover over ID, an argument that was passed into that game resolver, or sorry, that game query in the schema, we'll see that that is strongly typed as string. Same with game ID and player ID down here. Excellent. We're now starting to get some of that type information out of our schema and made available with inside of here. We don't have everything yet, but it's a good start. If we were to run our application, it wouldn't run any different, but that's all for step 5. We've started to get some type information brought in from our GraphQL schema, but for step 6, well, we're going to go a little bit further and look at how we can get even more strongly typed information made available. When we last tried to run our GraphQL server through the Apollo Studio and query for some of the data, it blew up. And the reason it was blowing up is that it didn't understand the differences between the models that we've got in our data structures in our database, or our pseudo database at least, and the data structures that we're returning from our GraphQL schema. We have a bit of that mismatch. Now, if you'll remember, we have, so on the question type inside of our schema, our question has a correct answer and answers. Whereas if we look at the type definition that we have on question, we have correct answer, incorrect answers, and they're cased differently. Well, this one's got underscores, whereas that was a Pascal case, and also answers doesn't actually exist as a model that we have anywhere. So how do we go about fixing that? Well, this is where we can use another feature of the GraphQL CodeGen tool that we introduced in our last step to add our custom types that we've got with inside of our TypeScript type system to the types that are generated from our GraphQL schema and help bridge that gap. Now, the first thing we want to do is, well, we want to address how these data sources are getting managed. And for doing that, we're going to come into our, where is our CodeGen? Here it is. And we need to do some mapping. So with our CodeGen, I'm going to add a new section within the way that we're generating this TS file, the generated.ts file. For the config, we're going to say for the context type, we're going to look for a file called Apollo context, and then its export is called Apollo context. So the hash indicates that the thing after this is an exported type, and then we're going to add that into the way that we're generating our resolvers. So let's pop the terminal, we'll come back into API, and then we'll do npm run gen. That will run our code generator. So now, when we have a look at our resolvers, it's strongly typed. We'll see that it's got a data source. It has user, game, and question. It knows about these data structures there. Excellent. But now we're starting to get red squiggles. Well, what it's saying is that we're expecting, so get game returns a promise of game model array, whereas get games is expected to return a different type. It's expected to return an array of game. Now, this is where our disconnectors happen between the type system that we've got in our schema and the type system in our application. But never fear, we can actually use the model mapping feature of GraphQL CodeGen to give it some information around how our models are defined. So let me just add another bit in here, bring this back to the correct tab depth, and then that should come back 1, 1, 1. I love YAML. Okay, so now what we've added is we've added some model mapping. So whenever you find a schema type of question, the type that is going to be available with inside of our type system in TypeScript is model. So this is for when we're mapping them from our resolvers. So our resolvers are going to be able to return a question model. But then we're still going to have to do some more stuff to make sure that everything wires up correctly when we return results in the right structure. But let's just go back to the terminal and we'll run our generate step again. Okay, that's done. Come back to our resolvers here. And then we should get that error should go away. What have I got? I've still got something incorrect somewhere. Wait, did that generate correctly? It did. Oh, no, sorry. Those are actually supposed to have been indented at the same level of config. I went up one too many levels. All good. Run that again. We'll rerun our generate. There we go. Okay, so that's done. Now we get rid of the red squigglies and everything is happy. So what we're doing is we're saying that the resolver for games is able to is expected to return a model, a game model type, because this is like a root level query. But we're going to still need to do some way to tell it how do we turn a game model into a game that we're expected to return from our GraphQL to our GraphQL clients. Well, for this we can expand the way that our resolvers are written. Right now, our resolver is only designed to work with. Just while I do this, we'll just go to npm start. So our resolvers are currently only written to handle our root level queries. So that is get games, and player results. But a resolver can also be used to tell the GraphQL server how to map a particular model that it's got to return back, or a type that it's got to return back from the data structures that it's got. So we can do this by we're going to add in a question. And you can see that I'm starting to get the IntelliSense here because it knows that question is something that I could be resolving with inside of my application. So we're going to say, okay, for question, let's just do control space. You'll see that I can say, well, how are you going to manage the answers, correct answers, ID, question, and is type of. We can ignore is type of because it's not really relevant for anything we'd want to custom map. But these other four, they're the fields that are available from a question. Well, how do we want to custom map them? Well, let's say for answers, this time we're going to create, it's going to be a function, but this time we're actually going to use the root that comes in. So this is going to be called question, because the root that's received by this is going to be a constructed object. And we'll have a look at the type information in just a moment. So question, you'll see that is a question model because that's what its parent has been. The parent that's been provided to this resolver is a question model. And now we could return, so we'll get the answers. We'll get const answers is going to be array randomizer. So we'll just import that. The question dot correct answer, incorrect answers dot concat, and then we'll pass in the question dot correct answer. Okay, so there we are, and then we're going to return answers. Oh, wait, I'm missing something at the end here. We are missing a parentheses. There we go. Have I got everything? So we've got yep. Oh, it's because the parentheses was there. My bad. Okay, so what we're doing is we're taking the incorrect answers array, we're appending onto the end of it the correct answers, getting that back, randomizing it, and then returning it. Because the expected return from here is going to be an array of string. So that's how we can take our internal data structure and then remap it for what we want to return out. I can also do that for correct answer because that needs to be custom mapped. So that will be question, and then for this we'll go return question dot correct answer. We don't have to do it for other fields, like for ID or question, because the default resolver will look for fields of the parent model type that are matching the expected model type. So ID and question are named the same and case the same, so we don't need to do any custom mappings there. This is just for ones where you either it's like a computed value, such as answers is, or it's maybe just like a case changing or a spelling change or whatever it might be. We would do that custom mapping. So now our server is still up and running. Let's come back to the Apollo Studio and let's see. I think it should be up and running. Oh, hang on a sec. Oops. Don't open full Visual Studio. Let's just see. Oh, no, hang on a sec. We ended up with an error, and that was because I have got an import somewhere. It's not that's missing. There we go. npm start. And while that started, let's just close down Visual Studio because I didn't mean to actually open that. Give it a sec. Let's go server. Here we go. TypeScript compilation passed. I've also updated it so that it runs the code generator as well. So everything is up and running. Our server's there. Come back to Apollo Studio. Turn it back on. It should detect that is now available, unless it's timed out. But let's just hit run and see whether it's working. Fingers crossed. I think unless I haven't got cores enabled. I might not have cores enabled. Let me check. Package. Yep, it should be enabled. Let's just reload here. It might have just timed out, or I've got something else that's gone wrong, and that's going to be highly frustrating. Something else has gone wrong. Let's find out. Where is this? Pop that into the browser. Make sure the server is actually running. Yep. API / GraphQL. GraphQL. Oh. Okay. It is up and running. But for some reason, it's not wanting to talk via cores to it. And that's going to be a fun one for me to have a play around with. Cores is star. Ran start host. Okay, let's just try npm. Actually, so func start cores equals. Okay, start again. See if it wants to work this time. If not, we'll pause the recording and I'll work out why, and we'll come back. Looks like that's not happy, actually. Why is that popping over there? No, I don't want there. I want Postman. Here we go. Let's open Postman. We can also use Postman to execute. I just don't find Postman as nice an experience when working with GraphQL servers because it doesn't. I can't seem to get it to poll the schema in the way that I want. But we can go here and let's just copy in this query that we're wanting to execute. And we'll send that off. There we go. It's definitely it's executed, so we can see that that function call has happened. And then, oh, sorry, that should have been a post, not a get. There we go. we managed to get it working. And also what we'll see is that it has successfully mapped that answers. If we were to come and have a look at our index.ts inside of types data. So this was our mock question that we had, and we'll see that our mock game that we had, and that we'll see that there's a bunch of not answers. We're interested in the questions. Oops. Where'd you go? Where'd you go, VS Code? There we go. So in HTML, which non-standard tag was used to make elements scroll. And then the correct answer is marquee in correct answers. Obviously, we got some HTML escaping there. The next question is, about qubits, so on and so forth. And we can see back in our Postman response. If I can, does this zoom in? Does a bit. Let's collapse that. Does that collapse? I don't use Postman much. I wish that would. So I'm probably just doing it wrong here. But yeah, you can see here's our question and here's the answers that were provided. So this is now successfully done all of that mapping because we've told it that about that custom structure that's here. So yeah, we've got that custom mapping. And yeah, like if we were to execute this, looks like, I think I've got the debugger up and running. Yep, there we go. Just saw that. So the question, you'll see that, there we go, the correct answer. So it had that's that question model. It's got those other fields in there. You'll see there's the correct answer. There's our incorrect answers array. And we can build that new answers array. If we do that, so we'll just step over. So now it is going to be in the order of scroll, marquee, slide, and move. Just remove that breakpoint. There we go. Scroll, marquee, slide, and move. So that's how we can do it. That's how you can. So what we've done there is we've added a bunch of custom additional model mappings for Apollo. So we've told it that it's going to be looking for our data context. So here's a type definition for our data context, so that when we write our resolvers understand what our context looks like, and it has a data sources field, and it has those 3 interfaces available in it. We've also told it that when you find these types inside of our type system, at the root level, we're going to actually have a question model that's going to be exposed, and then we're going to be able to map those fields through customly if we need to, which we've done by adding a question resolver as well, or at least a field resolver for a couple of the fields of that. So we're actually getting pretty good along the way here. Like we've got this sort of end-to-end mapping starting to happen. We're starting to get that real power of TypeScript inside of the application that we're building. Don't need to bring up the windows. I'm waving my hands around while I'm talking and hitting random buttons on my keyboard. And there goes our start menu. Next up, at the moment, our system is only read-only though. So next up, we're going to add in some mutations so we can make a writable system, because we're nearly there. We've completed 6 steps of our workshop so far. 2 more and we'll have a fully functioning application ready to go. But I'll see you back shortly for us to start building out our mutations. At the end of the last step, for some reason I wasn't able to get the Apollo Studio to work with our Graphql server so that we could play around with the newly updated versions that have that end-to-end type stuff set up. So we've switched over to Postman. Since then, I went to bed. It's a new day. The joys of editing and recording a workshop like this means that it can span over multiple days. I've come back and it seems to be working. So I'm going to chalk it up to no idea what went wrong. It was probably just I needed to restart the various servers that I had up and running, and VS Code and a few things like that. So I probably just had like a process that was hanging around that wasn't causing any problems. If you do have any issues, or if that's a repeated thing that you keep finding, do reach out to me so I can try and work through that issue with you, so that you're not blocked in a way that I kind of was. But that aside, it's time to continue on. And for this step, we're going to have a look at how we can do mutations. So in GraphQL, a mutation is any way that you're going to be changing data inside of your server, inside of your backend systems. So that's where the name obviously comes from. You're mutating the data, so it's a mutation. But what we're going to be doing here is we're going to be using mutations to do a few things. Right? We're going to be creating some games. We're going to be adding players to those games that are in progress. We're going to change game state. We're going to add answers to questions as players submit them, and that kind of stuff. So let's get started by building out a schema that's going to represent that new updated sets of things that we're going to have to do. Come down to the bottom of the schema here. Close off to the side. And for mutations, oftentimes you're going to have to pass arguments into them. And these arguments are things that we're going to want to strongly type, because they're going to represent a complex object of multiple fields that might come in. And the easiest way to do that is to create new types inside of our type system, inside of our schema, that we can then use. There's a special type that we use to denote that this is something that someone is going to be sending up as either a mutation or a query. You can use these as query inputs. Oh, excuse me. And these are called input types. So we go input, and let's say one of the things we're going to need to have is we're going to need to add a player to game. So add player to game. And then for this one, we're going to pass in the game ID, and that will be That will be an ID not nullable, and we'll have the player name, and that will also be a string that is not nullable. Another input type that we're going to need is a way for us to submit an answer. Now, to answer a question, we're going to need a bunch of information. And while the add player to game is probably not a particularly complex, it's only really two arguments that you're passing in. When we answer a question, we're going to need to know which game are you answering for, what question are you answering for, who's the player that's answering that, and then finally, what's the answer that they've selected from the list. So that's 4 different bits of input. So this is probably more useful as an input field. So for this, submit answer, and we'll have the game ID, which again will be ID. And we'll have player ID, ID of that, question ID, which will be our ID not nullable again, and then finally we'll have answer, which will just be a non-nullable string. So we're kind of forcing that they have to give an answer, or the downstream client that's calling this has to give some sort of an answer. And now we're going to create a mutation type, similar to what we did with query, where we defined like the entry points into this. So we go mutation, and let's see, what are the things that we're going to have to do here? We're going to need to create games. Currently, we have no way to create a new game, so we'll have a create game mutation, create game. So that's not going to take any arguments because it'll just initiate a new game, and that will return a game type. Like queries, mutations have to return something. We'll have add player to game, and then this one is going to receive some arguments, and it'll receive an input, which is the add player to game input. And for this one, let's think about what would be logical to return here. Maybe we'll return the player that's being created. So a mutation can obviously return anything that's relevant in this case. I'll have start game. This will just take the game ID. We'll just call it ID because there's only one ID in this case. And then that can return us, all those, we want that to return us the game. And lastly, we'll have submit answer, which we can then have the input being that submit answer, and then we'll have that return the, we'll get it to return the player. Yep. Excellent. Okay, now the last thing we need to do is we need to add this to our query. So we'll have mutation, and that will be mutation. There we go. All right, now if we were to pop our terminal and then run, sorry, I've got the server running and it's got a file system watcher on for everything, so it will automatically regenerate the files as we do it. So it's already regenerated our schema. Regenerated our TypeScript definitions. So let's have a look at those now. And if we come down further in this, we'll see, here we go, we have mutation resolvers. So these are the types that, it's picking up things like the context type, which is the Apollo context, which we created in the previous one, and use the schema to, the config for GraphQL CodeGen to say, here is a strongly typed context. I want you to, for the resolvers that you're generating, use that as the context. And we've got our create game, add player to game, etc. And we'll see that these have their resolvers. They've got the various fields in there, but we also have the these args that are getting passed in. So like add player to game mutation args. If we jump up here, we'll see that it's got an input, and then those are those fields that are inputs. And so we've got all these correct types, the same as we were getting for our queries, which means that if we were to come over to our resolvers.ts, we can now start filling this out. So let's collapse down query in question and player. In between cuts, I've also added some handlers for. So remember, with player, we can get back the game for a player. So these are things that you can do off the player object as well. So I've just added some of that stuff in there. Yep. And then we're going to create a mutation. So that IntelliSense has picked up that we now have mutation as something that we can add to this. And then that is going to be an object. And if we control space to bring up our IntelliSense, we'll see that we have those 4 new mutations that we've got in there. Let's start with create game because, well, it's going to be the first thing that we really need to be able to do. And it's going to be a function which will have, again, an ignored parent. It has no arguments passed in, and then we're going to need to get back our data sources from context. And again, we see that we're getting that type system is flowing through just nicely. And inside of create game, let's think, what's it going to do? Well, actually, no, this is probably going to need to be an async function because we're going to need to get some questions. So with const questions, and that will be await data sources dot question and get questions. So we'll get questions, which returns a promise. Oh, I'm not doing well on hitting the right characters on my keyboard today. It's obviously too early for me or something like that. And then we're going to create a game. Await data sources dot game dot create game. And then this one we're going to need to pass in our questions. Question. Oh, it should be questions because we're getting multiple back, not a single back. All right, and then lastly, we'll just return the game because that's what we're expecting to return back from this function. There we go. Our red squiggly has gone away from create game, but we need to go and actually implement what's create game going to be doing. And we are still using our in-memory data source. So we'll go to the game data source and not the Cosmos DB one. So now if you're having a look in the code base, you will actually see the implementation for working with Cosmos DB. So you can see how you do that. I won't bring that really up on camera because I'll leave that something for you to explore. We'll just keep it simple and use our in-memory one here. Right, so we need to implement this function called getGame. We'll also need to come back and do things like update game and a few things like that, but yeah, one thing at a time. So this is really going to be quite simple. We're going to create a new game object, and actually rather than me doing this entirely from memory, let me just grab it from my notes. So this is the advantage of having a scripted workshop, is I can go back and copy in the things that are relevant rather than having people have to watch me fumble around and keep putting apostrophes when I should be putting semicolons. Also, you're not here to watch me just type. You're here to actually see what we're trying to do and the outcome of that. All right, so we're creating a game. I'm just typing this as game model. I probably actually don't need to have that type in there. So, no, because it doesn't detect. I work across a couple of different programming languages, and another language that I work with does type inference, so that I don't need to strongly type things quite as much as this, and I kind of forget which mode I'm in sometimes. So we're using our ID generator function that we used previously when we were can't remember exactly when we brought that in, but we brought that in for a reason recently, where it's just going to generate 4 random characters and 4 random letters, and that's going to be the ID for a game. We're using the model type enum, which is the one that's generated from our GraphQL schema, because we want to keep that consistent. What we're storing in our data store is the same as what's represented by our schema. There's no point in having that enum created in TypeScript, because an enum is a much more primitive thing than we have with our object models. Oh, sorry, no. Model type is the one that indicates what this is. Game state is the one I was just referring to. We're setting up that we have we have no answers yet because the game, well, no one's submitted an answer yet. We have no players yet. They haven't joined the game because we're waiting for players. Because this is just running an in-memory collection, we'll just push that into there, and then we'll return that back as a promise just with promise.resolve. All right, so that should all be up and running. Let's come back into Apollo GraphQL here. And now if we come back to our, actually probably need to reload that. There we go. It did pick it up, the updated schema. If we come back to our root, we'll see that we have a mutation. So actually, we'll just run that example query. So this is that one that we've got hard coded still in our system, just as that mock game. So we could test to make sure that our queries were actually performing an operation. And that we're always returning no values otherwise. And we're like, oh, well, obviously it works, it's returning. We didn't know if it was returning the right thing. But now we've got our mutation. So we should be able to create a new game, and then this query will give us back multiples. So we're going to go to a mutation and we'll call create game. So I'll add that to the operations that are here. And it says, well, we need to select something back from that. And let's grab back the ID. We'll grab back the questions. And then from the questions, we'll grab back the question and the answers. Just as an example point. Let's execute that. And there we go, we've got a new game ID. It is GRPN, and it has a bunch of questions that we'll see there. Now, if we come back and run the example query up here where it's getting back the gains by their ID, we now have 2. Excellent. So we've created our first mutation that is now pushing data into our database and kind of leveraging that end to end. Now we have a couple of other mutations that we need to implement. We'll have add player to game. This one is again no argument, no root that we need to care about here, but we do have an input argument that we're going to care about. So we'll have an input, and then we're going to just do some unpacking of that. We'll have game ID and player ID, player name. Sorry, that's adding there, and we'll get our data sources, and what do we need? We need our closing parentheses, we need our open squiggles for this one. So we're going to need to do a few other things in here. We're going to need to get back the existing game. So we'll probably need to make this an async function. Async function, there we go. Sorry, I'm just getting my notes up on the other screen, and we'll const game equals await data sources dot game dot get game, and we'll pass in that game ID. We probably want to do some like null checking and stuff like that here. I'll skip over it because you don't want to try and like add a player to a game that doesn't exist. But that's in the full completed version, I'm pretty sure. Otherwise, feel free to add your own null checking if you want. And then we're going to do const. Let's see. We'll actually create a user. Const user is so we're going to have a create user function. So we'll double check to see if that's actually implemented yet, and then we will have game.players, and we'll push the new user in. Why don't I consistently name that player? Why is it called user there? Oh well. It's called user there for some reason, I'm sure. And then we'll call data sources.game.update game with the game. And then lastly, we'll return the user because we expect to return back a player object from here. So let's come into the in-memory. Oh yeah, so we do have update. Like for the in-memory one, update is really not doing anything because we're just mutating the in-memory data object anyway. So for user, let's have a look. Yep, I've already got create user implemented there. I either did that for like between cuts, or maybe I was lazy when I was lazy when I copy and pasted in the user data source implementation and had that in there. Now, what might be interesting to note is that this will actually reuse existing users. So if you use it, so the username is treated as a unique value. So if that user already exists, we'll just get that one. Otherwise, we'll generate a new user, add them to our user collection, and then return it back. All right, what other ones have we got to have? We've got to add a way to start a game. So this is probably another good one. We'll have ignore, and then it's my comma, there it is. This will have ID. So this is not using an input type. This is just using like an individual argument as the input. And then we'll get our data sources. There we go. And then actually it's going to need to be async. These are all going to probably need to be async. And I just will grab this from up here, get our game. That should be ID. Consistent naming is not a thing that I'm good at. Game.state will become GameState.started. And then we'll return the, actually we should do await data source dot game update game. Because if we're using Cosmos DB, we need to obviously do the write back and then return the game. Okay, and then last but not least, we need a submit answers. Actually, I'm going to copy in submit answers because it's a bit of a long function. Question ID. Oh, what did I call it in my schema? Question ID with a capital D. Let's, oops, ID. Name it like that. Go. Okay, excellent. And then we'll bring in the user answer model and the model type. So because an answer is like something that it's not necessarily stored as a separate object anywhere within inside of our system. It's just kind of embedded as part of the game object itself. We don't have a data source that's controlling answers. I mean, that's a decision that I've just made in the way that I've implemented this. You could feel free to go ahead and change that in any way that you prefer. But yeah, from an example standpoint, just was showing that you can, this is how we could do sort of like inline objects and stuff like that. But we have our input object here that I'm just decomposing as individual arguments so that we can use them without having to prefix everything with like input. We're doing promise.all on accessing the game, the user, and the question. So we're going to back a question by its ID, game by its ID, and player by their ID. Generating our answer model with an ID that's just made up out of the 3 imported segments. Put the appropriate bits of information in there, add it to the game, update the game, and then return the user. And probably would have made more sense to return the game at this point, but oh well, that's the way that's implemented. Now, though, that should all be up and running. So let's go through some of this stuff. Actually, let's add a couple more things to this. So we'll go add player to game. We'll add, we'll need to add that argument as a variable there. We'll come back and which game? We'll use this game here. So here, so in Apollo Studio, we'll have game. This is passing it in as JSON. So we'll do game ID is going to be that game ID. Oh no, that game ID won't exist yet because we've done some stuff that's forced our server to restart. Like we've changed our server. So yeah, I'll have to generate a new game ID, and then we'll have a player name. All right, there we go. And then we'll get back ID. What else shall we get? Just get back ID and name because that's returning us a player. And then do start game, which will take, again, we're going to need to have a few more fields that are defined here. We'll have the, start game just takes in the ID. So start game ID. That'll just be the ID of the game. Again, we're going to need to generate a game that we can do this with. And then lastly, we'll have submit answer. So start game, we'll just get back the state and then submit answer. Ooh, interesting. That's added it all to one single mutation, which is not ideal. I don't actually want it done that way. Okay, maybe this will be just a little bit complicated to try and run in Apollo Studio. let's get rid of everything. We'll start again. We'll go back to the mutation. Let's create a game, and we'll go back to the ID and execute that. Okay. So that's going to be our game ID. We are then going to come up and do a new mutation, and we'll add play to game. Who wants to add it to that one? I don't really want it in that one. That's all right. We can. Well, actually, you know what? Let's not play around. Let's not keep trying to play around with using this as a way to call our API. Let's instead continue on and actually start building a web UI that can use this server. We've seen that at least the basics of our updated stuff is working. So I can do create game, and we can get back our ID. So we know that we are performing mutations, like that is all end-to-end working. So let's go on to the next step, where we'll actually build out a web UI in React so that we can play this game and not just kind of poke at it through a GraphQL IDE. All right, I will see you back shortly for our final segment. Okay then, who is ready to finish off building our TypeScript GraphQL web application? I know I am. So far, all we've done is we've built a server API. A server API that's running a GraphQL server that's written in TypeScript, where we've been leveraging our TypeScript type system, and combining that with the GraphQL schema and the type system. But so far, we've just kind of been poking at it through a GraphQL IDE. Now it's time to go ahead and build out our UI component. I've mentioned it a couple of times, but we're going to do this in React. But the stuff that we're touching on is not React specific. I mean, other than obviously the code that we're writing, but the libraries that we're going to be using to work with GraphQL and to then generate a type-safe code for working with GraphQL from our client, that's applicable whether you're using React or Angular or Vue or Svelte or whatever framework you're preferring to use. So let's get started. For this exercise, I've actually scaffolded out a bit more of the web application. So it's a web application generated from Create React App. I've added in a couple of additional dependencies, React Router DOM being the main one, so that we can get our routing. So we've got our multiple pages. And I've also installed the Apollo client library for working with our GraphQL server. Now, the Apollo client library doesn't have to talk to an Apollo GraphQL server, it can talk to any GraphQL server, but obviously it makes sense in this case to be talking to an Apollo server because that's what we're using as our backend. I've also created the 4 pages that we're going to have in our application. We've got create a game, join a game, play a game, and complete a game. And we have then the appropriate routing configured within inside of our application. Now, to talk to GraphQL, I'm initializing the Apollo client, telling it where the API is going to live. It's going to be living at just /API/GraphQL. I'm using the proxy feature of Create React App to do that across the multiple ports that this application is running in. But yeah, you would point it to wherever is appropriate for like a production version that you're doing. With React, create a context, which we have the client provided to, so that we can then use it from within inside of our React components through the Apollo client library. We don't have to worry about its establishing connections and all that kind of stuff. It also means that we got a shared cache. This is just an in-memory cache, but you could have maybe a cache that uses like IndexedDB or something like that if you needed better caching for what you're building. Now, the first thing we want to do is we want to create a game. So we need to implement this create game page. And for that, we're going to need some way that we can talk to our GraphQL backend. So let's start by doing this. So we'll import we'll import some packages from the Apollo client. And the packages we're going to need are GQL, so we can write a GraphQL command, and then use mutation. Because this is a React app, I'm going to be using React hooks and function components. Pick the appropriate one for whatever UI framework that you're going to be working with. Inside of our component, well, actually, no, I probably don't need to create it within the component, but we'll create a const. We'll call this create game document. And then that will equal GQL, and then backticks And then inside of this, we'll write our mutation that we're going to be performing. So this is going to be a mutation. And this is create game. And then we'll just grab the ID field. Like that's really the only thing that we're going to need back from this. Like, so create game to go to the join screen. We're not going to need to have like the questions or anything like that yet. We'll get them when you're starting the actual game. Now let's start building out our component. We'll use our React hook here. Oops, squills. Create game. And that will equal use mutation. And then this time we pass through the, so for this mutation, we're going to pass in the GraphQL document node that we've created, which is the create game document. And then this mutation will invoke at some point in time to start the game. So let's just chuck in a button with an on click, and whoops. Create game, call that mutation, and then close that button and we'll say start. There we go. Okay. Let's launch the application and see how it's all going. Just make sure that everything's going to get up and running. For that, I've created a launch command inside of VS Code because we're going to need to run both the front end and the back end, and they're two separate APIs. So either you run npm start from two different terminals, or just going to run this full stack launch target that I've created in VS Code, which will start up the front, both the API and the backend server. API and the React application. So let's close our terminals. We don't need them up and running. Actually, no. Let's just check on the terminals. Oh, looks like something has errored out. Did I not run the generate, or did I not update this schema? No, those are updated. So it's not liking our resolvers. Our resolver. Oh wait, no. I think the generator might not have run before. No. Let's see. ID and name. Where are I writing my schema? It is add player to game, player ID in game. Input. Yeah, okay, let's just do npm run gen again and see if the code generator is working. Okay, so that did work. Okay, I think what happened was that it tried to do the TypeScript compilation before the code generator had actually updated with the change to the GraphQL schema. So then that failed because it's just using concurrently behind the scene to start everything. So let's just run npm start, and then that should all work. This is the kind of thing that you should be able to fix in editing, but I want the authentic feel of this is like a workshop, that not everything goes smoothly when you're doing demos and you're building workshops, and like we write code and bugs happen, and here's how we can fix them. Yeah, so there we go. It looks like it's all done. Let's relaunch this, and we'll bring up the network tab here on the side. Zoom that in a touch, and let's hit start our game. What we should see is a fetch request across to our GraphQL server, and then that should come back successfully. Excellent. And if we have a look at the request, we'll see that it's passed through that mutation. We'll look at the response. We'll see that we had create game. That was the response that came back. And then we got the ID, which is the field that we requested. Excellent. It's worked the way that we wanted it to work. But let's close off the stuff that was broken for a time being. The problem is that, well, if we have a look at this type signature we've got here, we're back to kind of where we were previously when we first started writing our GraphQL server. We have all this useful type information in our schema somewhere, but TypeScript just doesn't understand it. We made it understand it for our GraphQL schema for our server, but now we're in the client and our client doesn't understand the schema that's existing on our server. So how can we go about doing that? Well, we can do that by leveraging GraphQL CodeGen again. Now, rather than setting up CodeGen for 2 separate locations, I'm actually just going to extend the existing CodeGen. So for this, I'll just stop the backend server. There we go. That's what I wanted. And let's just make this terminal a bit bigger. So we'll reuse the server. The one implementation of GraphQL CodeGen. We don't want to have to run 2 separate ones because then we're making more of a mono repo and we have to deal with potential dependency drift and stuff like that. And what I'm going to do is I'm going to add a npm package. This is it's another plugin for GraphQL CodeGen. It's called Typed Document Node. And what this will do is allow us to generate the document nodes. So let's just hide our terminal. So this document node that we're passing through to the news mutation, this is just a generically typed document node. We can strongly type that one, and that's what this is going to generate for us. So we'll come back into our config codegen.yaml file. There it is. And we're going to add a new output that's going to be generated. So we can generate multiple outputs from here. And let's add a new one here at the bottom, which is going to be pushing it up into /source because this is running with inside of our API folder. We're going to generate generated.tsx. Well, it doesn't need to be TSX because this is just generating TypeScript. And there is some. So you can get it to generate. There is like specific React plugins if you want to generate React hooks. I used to have it doing that. I've obviously haven't updated my. I will fix that in the Git repo before the workshop actually happens. So you didn't see anything. But no, you can add it to if you want to generate higher order components for a React application or React hooks. So you can use it. You can do all that kind of stuff. I'm not doing that anymore. I'm actually using the typed document node because that's more portable across all different front-end frameworks. So now we've got plugins, which is going to be TypeScript, TypeScript operations, which I'll explain that one in just a moment, and then type document node. I'm also adding a hook into when we run the CodeGen. It's then going to run prettier over the files afterwards. That will then just format them appropriately. Otherwise, we would have files if we're running like a prettier test on our source code, maybe before part of a build step or before compiling or whatever like that. You might end up with files that are not matching the coding standards that you've got. So you can just get it to run prettier as well. Okay. So let's come back here. We'll do npm start. Actually, no. I forgot one other thing. I forgot to explain what those what it was meaning by operations. So up here we've got this document section with inside of our codegen.yaml file. It's currently set to null, but we're going to change this to be set to /source/operations/star.graphql. So what this is telling, what this is going to tell our code generator is that rather than us inlining this this here, it's called a GraphQL CodeGen calls it an operation. So it's an operation that you're performing from your client to consume GraphQL. Rather than having that embedded inside of our TypeScript application, I'm going to create a new folder and it will be called operations / and then we're going to start with create game.graphql. Okay, and we're going to grab this code. I'm going to pop that in here. So now we have an operations file. Like I said, that's just the name that it's used with inside of GraphQL CodeGen. And it will look for that and it will use this TypeScript operations to generate the appropriate things that we need for our client. Back to the terminal, npm start. So this will run our code generator again. Let's leave this up just to make sure that I didn't introduce any bugs. Yeah, excellent. It did have some bugs in it. I spoke too soon. I thought everything was going fast. I forgot to add the TypeScript operations npm package. Yes, of course. Oh dear. Npm I -d at GraphQL code gen slash TypeScript operations. Yeah. Well, I thought that one was already installed, but evidently not. We'll let's just install it. There we go. Now we can do npm start. Hopefully that it works this time. Otherwise I might have to do some editing. No, that's all right. We'll leave it all in. It's all good. There we go. Starting up. Code gen. Excellent. Well, no, don't say it. Yeah, there we go. No, it did pass that time. It did start. The code gen did work. Excellent. And now I can say excellent. Okay, so what we'll see is we have this generated.ts file down here. And we'll see that it's got a bit of similar stuff that we have with our like our server-side generated file. We'll see that we have the appropriate type, so like game state, question, etc. But if we come down to the bottom here, we have this document, and this is our actually no, one thing I forgot to this mutation actually needs a name. We'll call this create game, because otherwise it doesn't know how to refer to this one. So you should always actually name, so whether it's a mutation or a query, you should always give it a name like this for the set of operations that you're performing in here. Otherwise, you kind of don't know how to address that one if you're firing off multiples of it. Okay, so that's now generated properly. Here we go. And you'll see that this has, it's got a bunch of metadata about what's happening. So it's, what is it? It's a document, it's got a definition. It's going to be doing, it's called create game. It's going to be doing a query, a mutation against a field called create game. And then it's going to select back an ID field. So this is actually what that GQL was going to be generating for us anyway when it gets passed through. This is just done beforehand, so it's kind of like a precompile step for the GQL command. So now we can come back into our TS file or TSX file here, and we'll change that to create game document, and then we'll import that from our generated. Get rid of the unused imports. And it's basically working the same as before. So we're passing that in, but because this is using type document node, but it's then got, it's generated the generic arguments that need to go into that for us that we need. So now create game has a bunch of additional type information. So what we can do is, instead of it just executing create game and like, what do we do after that's completed? Well, we're going to want to grab out some fields, and for this, actually, we're going to make this a little bit more of an intelligent one. So we know when to call the various things. We're going to have some local state. We'll call this creating, and then set creating, and that will be a use state hook. That will start out as false because we're not creating the game yet. And then we'll have our create game, and then we're going to unpack the potential response information from this. So this will have loading. So what state is that operation in? We'll have call. Have you previously called this mutation? What is the data that's come back from the mutation, and were there any others? So that's all fairly useful. And we'll now have a use effect hook, and then this one will be a function that is if we're creating, then we'll call create game. Oops. Create game, there we go. And then otherwise we'll just ignore. And then this hook is going to need some arguments. Creating and create game. Excellent. And then we'll have a secondary hook that is going to be looking at the responses coming back from this mutation. So yeah, instead of clicking start there, we're just going to have set creating. So that's what it's going to do in here. And we'll have, set creating to true. And then we'll have that as disabled when we are commuting. So that's that done. So yeah, disable the button while we're creating. Now, once the game has been successfully called and we have got a new game back, we're going to route across to the next page, which is going to be join game. So we'll need to get back the history from React router hooks. React router and its hooks. History is going to be use history. There it is. And then we'll use an effect. Oops. And that done. And actually, I'm going to copy in some code because this is a little bit more verbose. And you'll get tedious. It'll be tedious watching me type in this. Okay, so if we're not loading and we've called, because we're not loading if we haven't also called it, because it's a Boolean value. It's not a tri-state Boolean value, which doesn't make a lot of sense. Well, doesn't, but let's ignore those semantics for the moment. Okay, so, and there wasn't an error, and we received data back in the response, and that data create game. So we kind of have to, like, this and you could probably clean up a little bit if you had, if you think more intelligently about the way that you want to structure some of the tests. Like, if we've loaded and we've called and there wasn't an error, ergo you can assume that is going to have a value. Like, there's no way that you would end up in that from the way the responses are structured, but the TypeScript type system doesn't understand that, or at least not the way that it's generating the code will it understand that. But assuming that we get all that back, now we have create game, which was the name of the mutation that we had here, create game, and we have an ID field, which is a string, which is not nullable because that's what we're expecting, which now we're getting that end-to-end type safety, all that sort of stuff that we want to, that we're hoping to get. I think that's really where we're aiming for, right? End-to-end type safety. Okay, so that's how we can create something that's going to call a mutation. Now, this mutation doesn't have any arguments, but we do have a bunch of mutations that do have arguments. So let's go ahead and do that. Join game is going to be the first one that we'll call that has arguments. When we route to here, we're going to get an ID parameter in, and that ID is going to be the ID of the game. So I'm just using use params to pop that out. So we're going to create a new mutation, and we're going to create a new mutation operation in here, and we'll call this add player to game, GraphQL. Okay, so this is the add player screen. It's got an operation which is going to call add player. It's actually doing two operations simultaneously as well. This is because, so one of the advantages of GraphQL is that I can perform multiple operations at the same time in the single request. So when we're adding the player to the game, we're also going to start the game. Now, this is obviously making the assumption that adding the player to the game doesn't result in an error, and like it doesn't crash at that step, because you could end up with a game that started that doesn't have players joined. But I'm kind of glossing over that because I wanted to illustrate how we could do multiple operations in a single GraphQL call. But yeah, so just be obviously aware of that in your own implementations. We're passing in two arguments here. We're passing in the ID and the name, so the ID of the game and the name of the player. And that ID is also used in this start game call. So it's turned into an input type that's being passed through to, let's be hitting that key again. It's being passed through to add player to game, but we're also passing it through to start game. So let's grab our, well, now that that's done, we can start implementing our join game. So we'll import use mutation from Apollo client. Okay, and then actually this page is big, so again we're going to cheat and be like, here's one I've prepared earlier. let's just bring in all of the missing imports, import all the missing imports. Ta-da. Okay, so history, name, so those hooks. Now we have our add player to game, which we have loading and data. And then this time we have an effect. Here I've just kind of simplified it again, just to show like a level of brevity that we can go, if there is data, then we're going to navigate across to the new page. Let's just have a look at that data object though. Because I'm using the add player to game ID. I mean, realistically, I could probably get away with, so that's the ID of the player. So we're navigating to play ID, that parameter that was passed in originally, and then add player to game. But if we go data dot, we'll see that we have add player to game and start game. And then we have start game has ID and players, which is all the things that we unpacked in this particular response. So yeah, if you wanted all of that information, you can get it back. We're not needing it here, so I've just kind of, but I've left it in there again for illustrative purposes. Okay, now we'll build out the rest of the React UI. Ta-da! Look at that. The magic of copy and paste. We now have our input screen where we have just a text field where we can type in our name, hit the button, and that will start adding player to game. And this time, when we call the add player to game mutation handler, we have to pass in an argument to that. An argument has a variables property. So there's a bunch of different arguments that we can pass in here. Oops, no, not paste, space. So around like how to perform the fetch operation, how long to wait, and that kind of stuff. So we can set additional stuff here, but the one that's most relevant in the problem that we're looking at here is variables. So we've passed in variables, and then we're passing in the ID and the name, which are obviously from the local state that we've been tracking. That request is going to fire off. That's going to send that to the server, and everything should theoretically just work. Let's start again, and let's just have a navigate through. So we'll start a new game, and then if I could type my own name, that'd be good. Obviously, we're not quite through to the playing game step, but we can see that this request happened. We got back a new game. We're going to join the game, play the game. So that's by game ID. We saw there's a second request here. The operation that we've performed was the mutation, which had all the various mutation things on it. We had our variables, which was the ID of the game and the name of the player. And then that came back with a response that we can see, we can unpack, and here's the players, here's me. So that operation has worked. It's performed as we wanted, and we can see that type safety mapping back and forth between everything. We have a couple more screens to complete. We got to add our play game screen. So I'm just going to copy and paste in this stuff because this screen in particular is quite long and verbose, and we're going to need to build out a couple of new operations. We're going to need to be able to get back a single game because we're not like, you might want to do something where you like push the game into like a state as you navigate around, but I'm going to have it so that this page will get a game as we navigate to it. So get game.graphql, and this will be this time's going to be a query. We'll call that get game, and that will be get game. Oh, this is going to need an ID passed in, so we'll have an argument that is $ID, and that will be an ID that's not nullable. That will then pass it through to ID $ID, and then what information are we going to need back here? We're probably going to need a bunch of stuff. We'll need the questions. Actually, let me check my notes to see what did I need back at this point in time. So get game. So yeah, we wanted, here it is. So we need the ID of the question and the answers, because that's what we're going to present to the user. We're also going to need to have a operation where we can submit the answer. So let's just let's create that one while we're here. This one we'll call answers.graphql. Answers.graphql. And so this submit answer. So this time it's going to be using the input type of submit answer. Now we come back to play game. That's generated all of our code because I've got the code gen running in the background. And how does this work? Well, so here we're unpacking the parameters when it comes in of the ID and the player, so the game ID and the player name. On load, to have an effect that will start up immediately. Initially, where is it? We're calling get game document. Okay, so as soon as we start, we use query. So this is a React hook from Apollo server, Apollo client that will then perform a hook against that document. So it's calling get game. We pass through that variable, which is the ID, and then we have the questions and so on and so forth. So we're waiting for this data to come back. So once with this effect, once we're no longer loading and the data has a game, we'll then set the questions as the array of questions that came back in that response. I have a little React hook that I've put in. I think it's in it's in the template just for working with set interval. So it's just a use interval hook. So you've got 30 seconds to complete the question. So that'll just run along. Every second that will count down. And then when you submit a question, it just pushes time remaining to 0 to force off the submitting of the answer. So that interval is completed, and then we'll have the we just keep updating questions as soon as until we get to the end of the questions as time counts down, and then finally, here's a example of how we can call a GraphQL operation that has a fairly complex input. So we have our variables, which has got the input, and then we're just creating a JavaScript object that we're passing through there, which is made up of all the relevant bits of information. Okay, and then I think the very last thing we need to do is we need to have a way to get back the information for the completed game screen. So let's have endgame.graphql. And this will get back the player results. So this is going to use that player results query that we created right at the start that will work with the player results information, but that obviously doesn't represent anything inside of our data models. It's just going to be essentially dynamically generated based off of information across things like player and question and game and stuff like that. And lastly, our create game. Let's create this page. Sorry, our complete game screen. Copy this one in. So it's going to be using that player results type document node, pass that through to use query, pass in the appropriate variables. We'll just wait for the answers. Once they're loaded, we'll iterate over them, display them, and then just indicate whether you got the answer correct or incorrect. And then we use dangerous set in HTML because they're HTML encoded. So that's all there. Let's start the game again. Let's start a new game because the game's actually been running in the background because I've got the watcher going. I forgot about that. So the game's been playing, and the way it's set up that if you time out and you haven't answered a question, it just submits nothing for you. So I was going to have a whole bunch of incorrect answers. Aaron has joined the game, and then here we go. I am not enough of a gamer to know the answer to some of these questions, so I'm just going to randomly click. What is the brain of the computer? Oh, I should get this one right. It's going to look really awkward if I don't get it right. I might have to edit out things. Striped and mirroring. I forget that. It's been a long time since I've run a raid. Haven't played Counter-Strike for a long time either. Okay, I'm just going to start clicking through because I want to get to the end. I just randomly click numbers. 104, I know that one. No. Oh, that's going to look really bad if I got it wrong. Okay, well, there we go. I I got most of the questions right. Wow, I actually got the Splatoon question correctly, and thankfully I got the CPU correct. Good. That would have looked really bad. Otherwise, yeah, I was just randomly clicking. Yay, number of keys on a Windows keyboard. Woohoo! I got some of the stuff correct. But there we go. We have created an end-to-end TypeScript application, React TypeScript front end using Apollo client to connect to an Apollo server that is written in TypeScript. We're using the GraphQL schema as a way to generate out a bunch of the type information that we've got. So it's generating the types that we use both server side and client side. We've gone through and created a bunch of operations that we can perform so that we can then generate out typed document nodes so that when we're performing those operations, in this case using React hooks, we get back our type information, so we know the structure that we have in that data result that we get so that we can then iterate over these. So we're getting all of that value of type information that we have. I'll do a little wrap up segment in just a moment, just reiterating where you can find out more information about this. But hopefully you've stuck with me through the workshop so far, and that you've got a working application just as well as I have. If not, jump through the completed folder and you can have a look at where you might have some differences in the implementation. But that's it for the actual hands-on coding. I'll see you in a moment for our wrap up. And that brings us to the end of our GraphQL and TypeScript workshop for TSConf 2021. I hope you've had a chance to play around with the workshop as we've gone along and built it and got it working. If you have, I'd love to hear from you. If you've had any troubles, again, please reach out. I want to make sure that you can get the most out of this workshop as you can. If you didn't grab the code when we got started, you can go back and find it at on my GitHub. It's a public repo at aka.ms/GraphQL-workshop/code, or you follow the QR code that's there on the screen. It's got all 8 steps are in there. They're documented each step of the way to give you instructions so that you can follow along and how to build the application. There's also the completed. If you just kind of want to jump through and see what it looks like when it's all fully done, you can have a look at how that works together. A lot of this couldn't be possible without open source tools such as GraphQL Code Generator. That is the tool that I've been using to bring that differences between our two type systems. The types that exist within inside of our GraphQL schema, bringing them into our TypeScript application. Whether you're building a client-side application or a server-side application, just want to give a shout out to them for building a fantastic tool for working with this. But that's all that I've got. Thank you for sticking with me. Thank you for attending this workshop, and I hope it's been enjoyable for you. Please do reach out if you've got any questions or anything like that. You'll find my details up here on the screen. But again, thanks and enjoy the rest of the event.